Good morning, students. Welcome back to Sunain Sir's online classes. In this video, I am going to explain you finding specific heat of solids or calorimeter experiment or activity used to find specific heat of unknown solid. This is very important question, 4 marks question in public examinations, regarding public examinations. I have seen that this question is repeated in every alternative years. That is, if this question is given in 2018 and not given in 2019, so there are 95% chances for this question to get this year. So I request you to listen this very carefully, and I am going to explain this very clearly in order to learn this question. So first of all, what is calorimeter? Calorimeter is a device which is used to find specific heat of unknown solids. And calorimeter is made up of copper because copper can conduct heat very fast. That is, copper is good conductor of heat. It will conduct heat very fast. And calorimeter consists of insulated vessel. Calorimeter consists of insulated vessel to carry water, that is to hold water, and it consists of thermometers to record the temperature of inside substance like water, lead shots, etc. And it also consists of a stirrer to mix all the substance inside the calorimeter. So this is the image of calorimeter. So calorimeter consists of thermometer to record the temperature of water. Inside the calorimeter there will be a vessel. As you can see here, in that vessel there will be water. This blue color one is water. And calorimeter consists of a stirrer. This is a stirrer. If you switch on this stirrer, all the contents present inside the calorimeter will be mixed thoroughly. So stirrer is used to mix the contents inside calorimeter thoroughly. Now let us go to the actual experiment. So first what you need to do is you need to measure the mass of the empty calorimeter by putting it on a weighing machine. Directly bring a weighing machine and put a calorimeter on this weighing machine. Place calorimeter, empty calorimeter on this weighing machine and note down what is the mass of empty calorimeter along with stirrer. Now mass of the empty calorimeter, we got it as M1. Take it as M1. Specific heat of calorimeter is SC. And initially calorimeter is at room temperature. That is why temperature of calorimeter is, we are taking it as T1. Initially it is at room temperature. Now you need to fill this calorimeter with water. Take a tub of water and pour it in calorimeter. Take a tub of water and pour it in calorimeter. Now place all this calorimeter. Now place this calorimeter which is filled with water on a weighing machine. Place a calorimeter which is filled with water on this weighing machine and record the mass shown by the weighing machine. Note down the mass which is shown by weighing machine. This mass is M2. Mass shown by the weighing machine is M2. So mass of the water plus calorimeter. Water plus calorimeter is M2. Now if you want only mass of water alone, then you need to subtract this calorimeter mass. That is, mass of water alone is M2 minus M1. And specific heat of water is SW. And temperature of water is also T1. Remember, water and calorimeter will always, they will be at same temperature because initially they are at room temperature. All the substance whichever present in the room, will be at same temperature. For example, you, your father, your mother, if you three are in the room, then you three people will have same temperature, whatever it is the temperature of the room. So calorimeter and water, they are present in the room, that is why they are at same temperature, that is T1. Next, this is tub of water. You need to take tub of water and you need to fill this water in the calorimeter and you need to measure the mass, and finally mass of the water is m2 minus m1. Next, what you need to take is, you need to take lead shots. Lead shots means nothing but simply like this iron balls or steel balls or balls which are made up of lead material. You know lead is nothing but plumbum, Pb. Chemical name is plumbum, Pb. So you need to take these iron balls or steel balls or lead shots, and after taking this, take this in a vessel and heat these lead shots. Heat these lead shots to a temperature T2. Heat these lead shots to a temperature T2 and then pour these lead shots into the calorimeter. Pour these lead shots into the calorimeter. First, what you need to do, you need to take some lead shots and heat them to a temperature T2 and then pour them into the calorimeter and measure the mass of calorimeter which is filled with water and lead shots. So finally, calorimeter plus water plus lead shots mass is m3. So if you want only mass of lead shots alone, then mass of lead shots alone is m3 minus m2. Mass of lead shots alone is m3 minus m2. Temperature of lead shots is T2. Specific heat of lead shots is S or simply SL. This is what we need to find, specific heat of lead shots. Our aim is to find the specific heat of lead shots, SL. Now let us recall once again masses of substances, masses of all substances. Mass of calorimeter is m1 and you need to remember these masses. Mass of calorimeter is m1 and mass of water is m2 minus m1 and mass of lead shots is m3 minus m2. Sorry, not m1 here, it is m2, m3 minus m2, m3 minus m2. Okay, now let us recall masses of now let us recall masses, temperatures of all substance. Let us recall temperatures of all substance. Recalling temperatures, temperature of calorimeter is T1, temperature of water is T1, both will be at same temperature, and temperature of lead shots is T2, and after pouring these lead shots, after some time all the substance will reach thermal equilibrium. After some time all the substance will come to the same temperature, that is final temperature of all substance is T3. Okay, remember, you need to remember these temperatures. Thermal equilibrium. After some time, after pouring these lead shots into the calorimeter, after some time all the substance will reach thermal equilibrium at a temperature T3. So according to principle of method of mixtures, net heat, whatever heat lost by lead shots is equal to heat gained by water plus calorimeter. Whatever the heat lost by lead shots, that heat will be gained by water plus calorimeter. Heat will be gained by water and calorimeter. Now let us see what is the heat lost by lead shots, what is the heat gained by water, and what is the heat gained by calorimeter. We know that heat formula is ms delta T. Heat formula is ms delta T. So let us find what is the heat lost by lead shots. Heat lost is formula ms delta T. Mass of the lead shots is m3 minus m2. Specific heat of the lead shots is SL, and temperature change of the lead shots. Initially lead shots are at temperature T2, finally they are temperature T3. That is why temperature change delta T is T2 minus T3. Now let us know what is the heat gained by calorimeter. Heat formula is always ms delta T. Mass of the calorimeter is m1. Specific heat of calorimeter is SC, and temperature change of calorimeter is, initially calorimeter is at T1, finally calorimeter is at T3. So final temperature minus initial temperature, that is T3 minus T1. Final minus initial, T3 minus T1. Now let us know what is the heat gained by water. We all know that heat formula is Ms delta T. Mass of the water is M2 minus M1. Specific heat of water is SW, and temperature change delta T is final minus initial, that is T3. Final temperature of water is T3 and initial temperature of water is T1. So final minus initial is T3 minus T1. Now according to principle of method of mixtures, heat lost is equal to heat gained. Heat lost by lead shots is M3 minus M2 into SL into T2 minus T3 is equal to heat gained by water. This is heat gained by calorimeter plus heat gained by water. Heat gained by calorimeter is M1 SC T3 minus T1 plus heat gained by calorimeter is M1 SC T3 minus T1 plus heat gained by water is M2 minus M1 SW T3 minus T1. So here you can take T3 minus T1 common. So if you take T3 minus T1 common, then remaining equation is M1 SC plus M2 minus M1 SW. This is the remaining equation on the other side. So here if you take T3 minus T1 common, then remaining thing is M1 SC plus M2 minus M1 into SW. Now send these two things on the other side in order to find SL. So on the other side, if you send M3 minus M2, since here it is in multiplication, here it will be divided. Here it is in T2 minus T3 is in multiplication this side. If you send it to other side, it will be in division, T2 minus T3. So finally SL is equal to T3 minus T1 if you take common M1 SC plus M2 minus M1 into SW divided by M3 minus M2 mass of the lead shots into temperature of the lead shots T2 minus T3. I hope it's clear. Thank you everyone.